Welcome to the webinar series organized by Climate Change Department, Government of Gujarat. I will request uh, Shri Bijal Shah, IAS Director JEDA, to welcome all the panel member and the participants.
Good morning and welcome to the esteemed participants in this today's webinar on vulnerability assessment. I warmly welcome the Principal Secretary of Climate Change Department, Government of Gujarat, Sri Haider sir, Professor Vimal Mishra, who is today's eminent speaker on the topic, and all other participants. Thank you. May I request our Principal Secretary, Sri Haider sir, to place with his speech.
Good morning, everybody. Dear colleagues, ladies and gentlemen, as all of you are aware, Climate Change Department, Government of Gujarat is organizing a webinar series of some 8 webinars attended by different experts from various organizations under the theme of climate change and COVID-19. Today, we are very glad to have amongst us Professor Vimal Mishra of the Indian Institute of Technology, Gandhinagar, who is going to speak on vulnerability assessment. We are thankful to him for sparing his valuable time, and he would be sharing his precious insight on this important ability. When we talk about climate change and when we talk about adaptation and mitigation measures, one thing which is uppermost in our minds is the identification of vulnerable groups. And the concept of vulnerability is very relevant, and it goes hand in hand with the adaptation and mitigation measures that we think of in terms of climate change. In general, in the state of Gujarat, like we talk about pastoral communities, we talk about people who are residing in coastal areas, we talk about people who are residing in rural areas, urban slums, and so on and so forth, as vulnerable communities. In the context of COVID-19, as you would have seen, one very important segment that is a vulnerable community is migrant laborers also. In the state of Gujarat, we have got close to 2.3 million migrant laborers. These are over and above native laborers. And I have been looking after certain aspects and supervising and monitoring certain aspects of the management of pandemic for Surat. And incidentally, Surat has got about close to 50% of the migrant laborers of the entire state. So these migrant laborers, how exactly they have been sort of handled, taken care of in a somewhat seamless fashion, although we didn't have any well-defined SOP, yet we created one. And I must say, although it's not like blowing one's own trumpet, and it's always a learning experience, and we were confronted with daunting challenges, and we came up with our own solution. And thanks to the level of coordination, the participation of NGOs, the participation of voluntary organizations, various government organizations, and coordination at different levels, we have been able to handle the aspect of migrant laborers in a very in a very, I should say, decent way in the district of Surat, and perhaps we can also, in due course of time, think in terms of carrying out a study and coming up with a case study for Surat. I was just deviating, but somehow I was tempted to talk about Surat and vulnerable communities, especially the migrant laborers of Surat. As all of us know, IIT Gandhinagar and IIM Ahmedabad are also helping the department in revising our state action plan on climate change. In the state action plan, a special chapter on Gujarat's climate change vulnerability assessment has also been included with an advanced set of data and IPCC methodology. Gujarat, as all of you know, has been working progressively under the guidance of Honorable Chief Minister Shri Vijay Bhai Rupani and Honorable Deputy Chief Minister Shri Nitin Bhai Patel in addressing the vulnerability of people of the state through various policies and programs. As all of us know, this department owes its existence to the vision of the then Chief Minister and Honorable Prime Minister Narendra Modi. And this department came up way back in September 2009, and we have been, in our own way, thinking in terms of, generally spreading the awareness, enlisting the popular participation, and seeing what best we can do in terms of adaptation and mitigation measures. I would also like to take this opportunity to welcome the association of our knowledge partners, Institute of Climate Change Research, the Maharaja Sayaji Rao University of Baroda, World Resources Institute, for helping us in knowledge dissemination, documentation, and technical deliberation in this evolving subject of climate change. Without much ado, once again, I would welcome all of you for having made it convenient to remain present in this all-important webinar. And I'm pretty sure that the deliberations in the webinar would be very fruitful and meaningful, and it would enlist proactive participation of all the participants. So once again, I thank all of you for your participation in this webinar series. Thank you.
Thank you, Honorable Principal Secretary, sir, for your opening remarks for today's webinar. I would now request the Director of Institute of Climate Change Research, the Maharaja Sayaji Rao University, who is also the knowledge partner of this webinar series. So Professor Sanskruti Majmudar to kindly give her remarks.
Thank you, Shwetal Bhai. Respected Haider sir, the Principal Secretary for Climate Change Department, Shri Mukesh Shah sir, Joint Secretary, Dr. Vimal Mishra, the speaker for today, very eminent speaker and deeply working on this subject, I would say. Shri Bijal Shah, the Director for GEDA, Shwetal Bhai, and the other invited guests and participants for today's webinar. First of all, I would like to thank Climate Change Department for including us, that is Institute of Climate Change Research, the Maharaja Sayaji Rao University of Baroda, as the knowledge partners for this webinar series. I'm glad to share that right now this webinar is being broadcasted live on 2 Facebook pages. That is the Facebook page of Institute of Climate Change Research, MS University, as well as the official Facebook page of the Maharaja Sayaji Rao University of Baroda. The advantage of doing this is that we will definitely get a wider outreach, and more than that, this webinar video will remain on the Facebook page. So because these will be working hours right now for few of the people, they can always go and revisit the page and attend the webinar post the event also. So that gives the advantage of a wider spread of the information of climate change. Because as we know, this is the necessity of the hour. Climate change is a subject which is affecting almost all aspects of our life, and it is important that we increase the spread of the information for this, not just to the researchers but to also the common citizens, so that we can get active participation from them for its mitigation. So once again, I will congratulate the Climate Change Department for coming up with this series of webinars, and it is our pleasure and privilege. So on behalf of the university, I thank you once again for including us as the knowledge partner for the series. Thank you.
Thank you, Sanskruti ma'am. I'm the presenter. Now I will request today's speaker, Professor Vimal Mishra sir, to address the audience with insightful presentation on climate change vulnerability assessment. Professor Vimal Mishra has pursued his doctorate in water resources area in the university in the United States of America. And Professor Vimal Mishra sir is right now faculty in civil engineering wing of the Indian Institute of Technology, Gandhinagar. Professor Vimal Mishra is advising Government of Gujarat and also Government of India in very important policy measures on climate change area, and sir's assessment in particularly hydrology and water resources has been very useful for the policymakers both at the national level as well as at the state level. Sir, now floor is yours. So you have around 45 to 50 minutes to address all of us.
All right. So thank you very much, Swetal bhai. Can you hear me? Swetal ji, can you hear me?
We can hear you, sir. Sir, you can share your slides.
Okay. Okay. Now, can you see the slides, Swetal?
Yes, sir, your slides are visible. Kindly full screen it.
And it's on full screen, right?
Yes, sir, it is now visible.
Okay, great. So thank you very much for inviting me for this today's very important webinar series that is organized by Gujarat Government of Climate Change in partnership with ICCR, MS University Baroda, and also World Resource Institute. So first of all, I will really like to congratulate Gujarat Government of Climate Change to take this very important initiative to start this seminar series. And I think that's very useful to sort of look back that where do we stand in terms of climate change and what we can do. I would like also to thank Sri Heather sir, Principal Secretary Government, Principal Secretary Government of Gujarat Climate Change Department. And I would like to welcome everybody who is connected with here today. And so, I mean, the vulnerability assessment was the topic given, but I have taken this opportunity to sort of go a little bit broader in the sense and understand the impact, risk, and vulnerability all together, so that it can give us a nice perspective that what are the risks, what are the impacts, and how we can use the vulnerability assessment for adaptation. Right. So in today's talk, what I am going to do, I will first discuss about the climate change 101, which is basics of climate change, and then I will look at the climate change projections. And after projections, I will look at the impacts. And in impacts, I would focus on a number of research findings done at Water and Climate Lab at IIT Gandhinagar. And then finally, we will discuss risk and vulnerability assessment. In that, I will share some of the results from the work that we have done for the Gujarat Government of Climate Change. As Heather Saab told that we along with IIM Ahmedabad, have been working to revise the state action plan on climate change for Gujarat government, right? So I will start now, and so first we will go climate change 101, basics of climate change, and that probably most of you know already, but I would still like to sort of revisit that global mean temperature of land and ocean has already increased roughly about 1 degree Celsius. If you go to pre-industrial level, that is 1850 to 1890 period. So there are evidence that temperature is rising at global scale, and that has different kind of implications. But the question is that whether this is the first time temperature has rising like this, or if we look in the history of the earth, that whether it has occurred earlier also or not. So, so if you look at the paleoclimate records going back to 400,000 years or so, you will see there has been a lot of time ups and downs in the CO2 concentration in the atmosphere as well as the temperature. So we see here that CO2 concentration in the atmosphere can go down as much as like 180 ppm, and it can again shoot back to 300 ppm. But what we can note here that in the history of 400,000 years, the CO2 concentration of atmosphere did not cross the 300 ppm mark. And also you see that temperature also goes like 3 degree warmer, and then also it can go to as low as 8 degree cooler. And this happens, and this has been happening in the history of our record as the paleoclimate data from the ice core suggests. So why is the climate change is a problem now, right? Why we should be worried about climate change? But what we can see from these two figures, that if you look at the bottom figure that shows temperature change from, going back to 400,000 years, we find that temperature from going roughly about -8 degree to 2 degree or 2.5 degree, this happened roughly in like 20,000 years or 25,000 years of time scale, right? So that's very important, that this changes that Earth had witnessed historically, what was the time scale associated with that? And this has time scale of 50,000 years, and mostly driven by the solar cycle that we know about. So now, what is the problem and why the climate change has become all of a sudden a problem? And that is the question we need to really understand a little bit in more details. So if we see the past record, even going back to 800,000 years, you see interglaciation and glacial periods. Then, but most of the time CO2 concentration was below 300 ppm. But if you see the CO2 concentration in 2018, that has gone up to like 407 or more ppm in the atmosphere. And as of now, June 24, 2020, CO2 concentration has reached to 416 ppm. And if you again compare with the time scale, the changes, time scale in which the changes were occurring historically, you will find that this time scale is very, very small in comparison to the historical time period when we witnessed, or Earth system witnessed, these kind of changes. So that has become unprecedented, that the increase in CO2 concentration in atmosphere roughly in 100 or 150 years and the kind of increase has been unprecedented. And that poses a lot of challenges, like if you increase the CO2 concentration in atmosphere, of course, the temperature will increase, as we have seen in the previous slide, and that will create other implications and impacts in different sectors. And that's why we should be worried about climate change. Now, the other question people often ask that, what is the evidence that climate change is anthropogenic? So most often we say anthropogenic climate change means that is caused by human beings. So here you can see in this plot different kind of climate forcings that can affect the temperature. And the biggest one is the greenhouse gases at the top in red color. And then you have observations showing in black dots and fitted with the gray line like, and you have other forcings like aerosols and volcano eruption. So the net result of these forcing is the gray line that we see. And what we can get from here is that the solar forcing is very, very minute if you compare to greenhouse gases emissions and the impact of greenhouse gases emissions on the temperature rise. So this is entirely or mostly attributed to anthropogenic greenhouse gases emissions that started after the industrial era, or because of the industrialized. So now let's go a little bit deep in the most important graphs. So I will discuss three most important graphs about the climate change. And first is the greenhouse gas emissions by major and other gases have been converted into the equivalent global warming potential. So what we see here, the CO2 emissions from fossil fuel is the biggest or largest contributor contributing more than 62%. Then CO2 emissions because of land use change like deforestation, CO2 emissions because of chemical. So if you add all these three CO2 emissions, sources, we can get like roughly 76%, and then 16% is from methane. So it becomes like 76 plus 16, 92%, and then rest are HFCs and CFCs and N2O, right? So fossil fuel emission has been the biggest cause of this greenhouse rise in the greenhouse gases emission. But there are other factors like land use change and the CO2 emissions from chemicals, or the permafrost thawing, or the CS4 or methane emissions from the agriculture sector. So this gives us, in a sense, that what are the major sources that are causing the rise in greenhouse gases emissions that we have seen in the previous slide, suggesting that the greenhouse gases emissions from the anthropogenic factors is the biggest factor behind the change in or rise in temperature in last 100 or 50 or so years. The second is that what activities do we do that basically emit greenhouse gases? So this is the partition, like 25% comes from the electricity generation, 24% comes from food and land use. So we can see that food and land use change contribute almost as much as the electricity generation. And then 14% from transportation, 21% from industry. So if we get the number like electricity, food and land use and industry contribute more than 20% of the total greenhouse gas emissions. And then there are some other factors like buildings and other energy sources, 6% and 10% respectively. So what we can learn from this figure is that food habits and land use change contribute as much as electricity generation to greenhouse gas emissions. And now when we emit CO2 to atmosphere, what happens basically? Where does it go and how it is partitioned? So that tells us what happens to greenhouse gases emissions. So long-term increase in the atmospheric CO2. So 45% remains in the atmosphere, and that causes like long-term increase in GHGs, or what we have seen like why CO2 concentration in atmosphere has become 416 ppm today, comparing to it has never reached above 300 ppm historically, even if you go to 800,000 years back in the Earth's history, right? So 45% remains in the atmosphere, and but 55% roughly or 54% comes back, and that can be absorbed by land-based sinks of carbon dioxide like forest, and then ocean-based sinks of carbon dioxide. But both of these have its own limitations, right? So ocean acidification can reduce the capacity to absorb CO2. So the capacity as sink can be reduced in future if we keep increasing the greenhouse gases in the atmosphere. So what we have to basically learn from this figure that whatever greenhouse gases are emitted, 45% remain in the atmosphere, and these are the major causes basically why we are witnessing the rise in temperature and problem of climate change. So this is basically a figure to give you an idea that how if you get the 1884 temperature with respect to 1951 to 1980 average, how the 1884 temperature will look like. And if you see the scale, you will see the temperature was like 2 degree to 3 degree or at least more than 1 degree cooler at majority of places in the earth. Okay. Now, if you compare that figure with 2019 relative to 1951 to 1980 mean, this is the situation, and you see that temperature in the northern latitudes, especially Arctic or in Siberia, has increased significantly, more than 2 degree or more than 1.5 degrees Celsius. So we have now we know that why it has happened and what it can cause. So I don't know. I mean, many of you have heard this news very recently. Came like in Siberia, the temperature reached more than 38 degrees Celsius. I think it's around 22nd of June, and it happened first time in the history. So in the entire record of last many years, temperature did not cross that limit. So 38 degree in Siberia, and it is now causing forest fire and different other kind of implications like dying of permafrost and so on and so forth. So now, I mean, now up to now, we know that what are the climate change, what are the factors of climate change, why climate change is anthropogenic, why climate change is a problem, right? Why it doesn't make sense to compare it with the rise in temperature or rise in CO2 concentration historically, going back to 400,000 years. So now we will discuss like what are the climate projections and what we can get from climate projections and why those are important. So IPCC released a summary for policymakers from it's a special report, and I guess it came around 2 to 3 years back, and where they sort of attributed that human activities caused approximately 1 degree Celsius global warming from the pre-industrial level, and that's what we have seen in the previous slides, right? Not only that, global warming is likely to reach 1.5 degree between 2030 to 2050 if we continue the greenhouse gases emissions with the current rate. So the temperature will become 1.5 degree warmer than the pre-industrial level by 2030, and 2030 is not far away. It's just 10 years from now, right? Now, what are the implications of these changes? The implications are that because of this rise in temperature, intensity and frequency of climate and extreme weather events have increased. And there is a large degree of confidence that basically mean temperature in over land and oceans has increased in most of the places. So as hot extremes, extreme hot days or extreme warm nights have increased, very high confidence in that. And there is also a medium degree of confidence that there has been increase in heavy rainfall events and the frequency of droughts in some parts of the globe. So CMIP 6 is basically there now. We are going to have the CMIP 6 projections very soon, right? And so what this slide tells us that what are the different scenarios and what do they mean in terms of projections. Now, why do we want projections? We want projections to understand that if we go with certain scenario, how much temperature change will happen and how that may affect our other sectors in terms of impacts like water, agriculture, forestry, or aquatic ecosystems in rivers. And so, so basically, there are different number of scenarios have been used basically in CMIP 6, and you can see going from green color to dark red colors and green colors. So like if we follow the strong mitigation, so by 2100, if we follow the strong mitigation, we may see temperature rise not more than 1.5 degree or between 1.5 to 2 degrees Celsius. And that will happen when we follow very strong mitigation, right? If we don't follow mitigation, then there are other scenarios like SSP 7, SSP 4, 3.4, and SSP 5, 8.5. So if we go like worst case scenario, we don't do any mitigation, we can reach like we can see as high as more than 4 degree or 4.5 degree rise in global mean temperature by the end of 21st century. Okay, so CMIP 6 has involved SSP, which is shared socioeconomic pathways, and those are basically considering sustainability, SSP 1, and SSP 5 is fossil fuel based development. So we don't cut the use of fossil fuel, and we generate our electricity mostly from the fossil fuel. And then what would be the shared socioeconomic pathway? And then it is combined with the radiative forcing like 8.5. That means there will be an increase of 8.5 watt per meter square in radiative forcing by the end of 21st century. So they also gave provided like different, if you see in this right side of your slide in the bottom, there are also like different distribution is given of different greenhouse gases, radiative forcings. You can see that CO2 is the major player along with CH4, but there are some forcings like aerosols that act in negative. So industrial aerosols basically reduce the temperature, right? And that's what we have seen in the slide where we discuss the different radiative forcings and why the climate changes and anthropogenic. So these are the scenarios basically developed by CMIP 6. IPCC is coming with the report, I think early next year or by the end of this year. So we can use these scenarios for impact assessment. Remember, these scenarios are projections. These are not predictions. Projections mean if you consider this scenario, how much temperature rise can happen and how that temperature rise will translate into the impacts in different sectors, right? Now, if I ask this, like which scenario would be the most suitable for our country? I mean, we have to look the trajectory of last 30, 40 years, that which scenario we have been following and what is the probability or possibility that India is going between these two scenarios or these three scenarios. And based on that, basically, we can generate projections and do the impact assessment. So, yeah, I mean, we have in our lab, we have downloaded this data and looked at basically that what are the different projections suggest in terms of rainfall or precipitation in different scenarios. And you can see that this is for South Asia, but you can also take a look at the Indian part, that we are going to go into better and warmer climate. And temperature can be as high as between 3 to 4 degrees by the end of century in the worst case scenario. Right? So what happens when you change the mean temperature or change the variability of the climate system? So if you can change the means, if you change the mean temperature, you will get more and more extremes. As you can see, the probability of occurrence of extreme events like hot weather or recorded hot days or warm nights will increase. If you increase the variability, you may also see the both kind of events occurring more frequently, like extreme cold events as well as extreme hot events. So we can basically see that how the variability and mean is going to change from these projections that are given by CMIP 6 or IPCC. And then we identify that how much increase in extreme weather events is caused by change in mean in temperature or by the change in variability in temperature, right? Now I will go to impact. So we have covered two parts. First was the basics of climate change, and the second was climate change projections. So now we are moving into climate change impacts, and we know that if temperature, rainfall changes or other climate variable changes, there will be impact in different sectors, starting from agriculture, water resources, public health, electricity demands, or electricity generation from hydropower, right? So this is this slide that gives you basically an idea that what kind of impacts we can see because of the climate change in temperature, rainfall, and sea level rise on health, agriculture, forest, water resources, coastal areas, and so on and so forth. So now I will discuss some of our work that basically gives us an idea that what basically climate change projects and what do climate change projections mean for India. And I will discuss very quickly because of the lack of the time. So basically, if you increase the temperature 2 degrees from the pre-industrial level, there could be 7 times more hottest summer that we have observed in the history. So here we looked at different climate regions. We identified the hottest summer, how hot occurred in last 60 or 70 years, and then we estimated the probability of these hottest summers in the occurrence in the 2 degree warmer world. So if you change the temperature 2 degree global mean temperature from the pre-industrial level, how often these hottest summer that occurred only once in 70 years will occur. And we found that there will be roughly minimum 7-fold rise. In some climatic zones, it may be more than 7-fold, maybe 10-fold rise of these. So they will occur more frequently. So that is basically very robust result when it comes about the extreme hot temperature or hot summers, how they are likely to increase in the future. Now, if you increase the temperature or because of the climate change more than 1.5 or 2 degrees Celsius, there will be tremendous increase in heat wave exposure in India. And heat wave exposure means if we compare like mega heat waves that occurred in the history, like 1998 heat wave that caused more than 2,000 people mortality, and 2015 heat waves, and you can see in the figures that what are the areas were affected by these 2 heat waves. So what would be the probability of these kind of heat waves occurring if we go into 1.5 or 2 degree warmer world? And we see that there would be a considerable increase, and in some areas with some projections it suggests it could be like 10 to 20 times increase of that kind of heat waves by the end of 21st century in the worst case scenario of RCP 8.5. Now, I mean, heat waves, mostly we use maximum temperature, but the problem with the maximum temperature is that it doesn't account for the nighttime temperature, right? So we looked at in one of our papers that what would happen to concurrent day and nighttime heat waves. So why it is important? Because if nighttime temperatures are cooler or less hot, then we get some relief during the nighttime from the heat. But what are the chances that both day and nighttime concurrent heat waves will occur in India? And that we looked at in the historic past, in the observations also, how these events have increased, and we found that there has been a considerable increase in these concurrent day and nighttime heat waves, and those are likely to increase in the future also. So not only temperature extremes, we are going to witness the droughts or dryness or increased droughts in India under 1.52 or 2.5 degrees Celsius. And in this work, we have shown like that dryness will increase in future. And these are all published papers. I will share the reference if you want to know more about these. And that will cause basically considerable increase. You can see that how the best GCM suggests the increase in dryness if the temperature goes more than 2 degree or 2.5 degree Celsius. And remember that 2 degree is very if we do very strong mitigation, then that is the possibility. Otherwise, it would go beyond 2 degrees Celsius by the end of 21st century. So we also looked at like how hot and dry summer extremes or hot and dry summer monsoon will change in future, and this is also published work. We linked that basically that how the frequency will increase in the future and how it will affect the food production. Right, in India we have made tremendous progress in increasing the food grain yields or the crop yields, and we have become self-sufficient in terms of food availability or food production. But if we get frequent hot extremes and dry extremes in the future, that have a very serious implications for the food production or agricultural production, right? Okay, so that was about the temperature and droughts or dryness. Now I will focus on the precipitation events. And in this, basically, whether precipitation events have increased, whether those are caused by anthropogenic warming. So these are, and what do you mean by increase in precipitation events, whether floods have increased or not in India. So these are the basically a few papers that we have published in the past few years. I will quickly discuss. And once again, if you want to know more, there is a list at the end of these slides. You can always look at. So what we basically studied here, that whether increase in precipitation extremes is caused by anthropogenic warming, because precipitation increase can happen because of climate variability also. So we looked at historical natural as well as historic projections that include the greenhouse gas emissions, and we found out that what is the difference between these two, and that suggests that in historical, which has the greenhouse gas anthropogenic greenhouse gas emissions, there is a significant increase in the extreme precipitation event. So both daily and multi-day extreme precipitation, remember multi-day extreme precipitation, if rainfall, extreme rainfall continues 2 to 3 days or more, those cause flooding mostly, those have or those are likely to increase in the future as these projections suggest. Basically by the end of 21st century, you can see that in South India or parts of North India also going to witness the increase in extreme precipitation events. So that increase in extreme precipitation will also create flood risk. And I would again highlight that the work on national level flood assessment has not been basically, there is not much around. So we looked at that how floods will change because of rise in temperature, global mean temperature. So we ran our model. We first looked at extreme precipitation events. Those are going to increase in future in different river basins, and multi-day extreme precipitation events like 3-day extreme precipitation events are going to even increase in large numbers in majority of these river basins, and that will create more frequent floods basically in India or the Indian subcontinental river basin. Now you can also see the difference between low emission scenario and high emission scenario, how the frequency of floods is different in these two scenarios. So what does it mean? It means that if we do climate change mitigation, and if we limit the global mean temperature below 1.5 or 2 degrees Celsius from the pre-industrial level, we can reduce the flood extremes, or we can reduce the increase in the flood extremes in different river basins in comparison to worst case scenario of RCP 8.5. So that helped us to understand that how important is the climate change mitigation. Right. Not only that, we see more frequently urban floods, and there has been a lot of work on urban floods by different institutes, including ISC Bangalore, Indian Institute of Technology, Bombay. We also looked at that how sub-daily rainfall extremes will change, and that has strong implications for urban flooding. So we looked at cities in India, I think around 50 or so large cities, and we estimated that what would be the change in design storms, or how the floods or extreme rainfall events will change in these cities. And most of the models basically project a tremendous increase in these cities. Like here you can see that if temperature increases from 1.5 degree to 2 degree, and there is roughly 12.8% increase in 3-hour 100-year return period precipitation. But if we go towards 2.5 degree rise in global mean temperature, the increase is more than 20% in different cities. So cities in future are likely to witness more frequent flooding because of rise in extreme precipitation. So we also, I mean, we are doing a lot of work on Gujarat, especially in the Gujarat government climate, in revising the state action plan on climate change for Gujarat state. And I mean, a lot of work. So whatever we have shown so far at all India level, we have repeated the analysis using high resolution projections for the Gujarat state. And these projections are available, and we have done vulnerability assessment. So what happened in Gujarat? So you see that there is a considerable rise in temperature in pre-monsoon, monsoon, and post-monsoon season. Also, the number of days above 40 degrees Celsius have also gone up, right? So not only at country level, there are regional scale variabilities and regional scale changes that we have to understand, because those are more relevant for adaptation and vulnerability assessment. Not only that, so Gujarat has witnessed increase in temperature, also increase in monsoon season rainfall, and very strong increase in extreme rainfall. So this Western India part continuously getting more and more heavy rainfall events, as you can see for Gujarat on the right-hand side, top panel, right-hand side, that there has been a considerable increase in this over last 60 or 65 years. Remarkably, that trends in number of rainy days have declined. And you know that this is consistent across the Gujarat. So Gujarat is receiving less number of rainy days, and that is also consistent for probably for India also, that number of low intensity rainy days or number of total number of rainy days has gone down, and total rainfall and extreme rainfall has gone up. So this means that we are getting more rain in less number of days, creating flooding and other sort of problem for agriculture and other sectors, reservoir operation and so on and so forth. These are some other projections suggesting that monsoon season precipitation is going to increase in Gujarat in different scenarios in different time periods, and also that there are projections suggesting that frequency of extreme precipitation will increase. So after this, I will talk about quickly about risk and vulnerability assessment. So far, we have done like there are impacts of climate change. There are indicators suggesting that extreme weather and climate events are increasing, and those will pose risk, and those can increase the vulnerability and exposure of people. So let's understand this part also, and this will be the final part of my talk. So what is risk? A risk is basically, let's say if we know that extreme rainfall will happen, we can identify what is the probability of extreme rainfall, one day 100-year return period event in future if the temperature goes up to 1.5 or 2 degrees Celsius. And as we have seen that frequency is increasing, so this probability will go down. So the likelihood will increase in future, right? And likelihood will increase. And then what would be the consequence of that event? Like if urban flooding happens, what is the consequence? How much damage happens to infrastructure? What is the loss to revenue to different companies? What are the other consequences? And if you basically multiply these two, you can quantify the risk. And that's what basically risk assessment most often does. IPCC Spatial Assessment Report has given a clear guideline on the risk assessment or disaster risk assessment. And as you see your left, climate has two factors, natural variability and anthropogenic climate change. So it's not true like if there was no anthropogenic climate change, flood would never happen. They will happen. Extreme rainfall will also happen. We will see hot summers mostly because of the natural climate variability. So these two factors contribute to extreme weather and climate events. And given that what is the exposure and vulnerability, and you basically you can identify the disaster risk, and then you have to think about the development plans for disaster risk reduction and climate change adaptation. Right, so this is more elaborated. You will understand probably more from this slide than the previous slide. So what it says that there is an inflation in all these three components: hazard, vulnerability, and exposure. And at the center we have risk. So how we can reduce the hazards or likelihood of the hazard, right? And how we can reduce the vulnerability, how we can reduce the exposure, and then overall we can reduce the risk because of climate change or risk because of disasters. Like example is you can use like ecosystem-based measure to reduce coastal flooding, right? Mangrove plantation and so on and so forth. And then you can reduce exposure by retreating and resettlement of the coastal community, right? And you can reduce the vulnerability by providing more social protection or livelihood diversification, providing insurance or hazard-proof housing and infrastructure. So we can imagine that reducing vulnerability and exposure, or even reducing the risk from the hazard, has a very tremendous cost involved, and that is the cost of adaptation. So that increases in future as we get more and more risk from extreme weather events like precipitation extremes or floods or drought. So risk of increased climate extremes has changed or increased and likely to rise in the future, and that includes multiple different factors or multiple different like droughts, floods, heat waves, reservoir storage, managing water, managing agricultural, unseasonal rains, probability of unseasonal rains. So what we have done for the Gujarat government of climate change, we have mapped socioeconomic indicators using the census data of 2001. Of course, 2011 census can provide a lot of new indicators and better data sets probably we use to just look at that, what is the exposure, what is the adaptability, what is the sensitivity and vulnerability in different districts of Gujarat. So this was pulled out for each district, and that we have mapped based on number of socioeconomic indicators like how far is the hospital, how whether there is a connectivity to road, what is the income level, what are the distribution of demographic distribution, and so on and so forth. So Professor Udit Bhatia has done very nice work, in this regard. And then we have basically mapped and do sort of that how these indicators are going to change in different districts. So how the exposure will change from 2006 to 2080, and you can see Kutch exposure and vulnerability is going to increase significantly. Or what would be the change in vulnerability for all the districts with change in exposure? So you see that vulnerability and exposure both are going to increase because of climate change or rising temperatures. Now, the final slide is this one, and here I would like to quickly highlight that there are guidelines of for the adaptation, and climate change adaptation and mitigation are both important. Mitigation takes a long time, but adaptation is basically need or urgent need. You can say that how to do adaptation to avoid flood risk or to reduce the exposure and vulnerability of people who might be basically exposed to different kind of floods. So FAO, Food and Agricultural Organization, has given the guideline, and that involves several steps, and that is basically more sort of for policymakers. Science is one part, policy is one part, and then the adaptation and then implementation to village level or block level or district level is the other part. So climate change has a series of action level, and only at one place if action is being taken, that may not be very fruitful. So what FAO has suggested that data and knowledge for impact and vulnerability assessment and adaptation. As we have seen through this presentation, that without data, we cannot even know that where we have come in last 20 years in terms of climate change, and what are the projections suggesting for our state, for our district, or for our country in next 30 or 50 years. Not only that, we have to have a very strong observations, and not only observations related to climate and weather, but also the socioeconomic indicators, right, for the vulnerability assessment. And that kind of a data will basically is required, and that is needed for the robust assessment of the vulnerability when we talk about the vulnerability assessment or exposure assessment for the climate change adaptation. Right, then we need institutions, policies, and financing to strengthen adaptation, and that is happening. Like Gujarat government of climate change has been doing tremendous work and shown the leadership, I would say, across country, and like ICCR. So we need more institutions that can increase the awareness, or the programs like this webinar series, or basically the program that can make people in rural areas aware about the government policies, or the financing options, subsidy options, or how government is helping local communities to reduce the vulnerability or exposure. Sustainability is basically a big word, buzzword. Everybody knows about it nowadays. And climate is smart management. We need, so not only Gujarat government of climate change, but all other departments should have climate smart management cell. That how revenue department is being influenced because of climate change in the Gujarat, or how in next 20 or 30 years water resources or agricultural department will face challenges. So that is needed at all level. Then we also need technologies, practices, and process for adaptation, right? Do we have technologies to do better forecast or early warning for the extreme weather events, or the unseasonal rains that happen mostly during the winter season in India? So that we need for adaptation. And finally, disaster risk management. And if you remember, disaster risk management includes everything. I mean, reducing the hazard or the likelihood of hazard, then exposure, and then also the vulnerability. And likelihood of hazard means we cannot change the climate or weather. We cannot stop flooding to happen. We cannot stop extreme precipitation to happen. But what we can do, like if area is facing coastal flooding, we can do some adaptation measures like mangrove plantation. Or if there is a, coastal water, saline water intrusion to coastal aquifers, we can change our groundwater pumping scenarios in those areas to avoid that. So that's meant by how we can reduce the effect or implications of the hazards that are occurring in increased frequency because of climate change. So I think that is the last slide. So in summary, what I have discussed today, basically, first I have discussed the climate change basics, like why climate change is anthropogenic, why we should worry about the climate change, why the argument of that climate change has been happening in last many times in last 400,000 years. So this is nothing new. That argument is not valid. And the argument that climate change is caused by solar forcings, or it is not caused by anthropogenic, is also not real. And then we looked at the climate change projections. What are different scenarios? What are data sets available? Remember, projections are not predictions. So we just can develop the scenarios to get some insights that what we can do to avoid the risk. And then we looked at the impacts, and there we studied, or we discussed number of things based on the published literature, that how India is going to witness frequent heat waves, droughts, floods, and urban extreme rainfall events. And in the last part, we discussed risk and vulnerability assessment. And I have also shown you some slides related to Gujarat government. I mean, the work we have been doing on Gujarat. I mean, we have done a lot of work, but I mean, soon we will submit the report to Gujarat government of climate change, and I can say that would be sort of a very detailed report looking at multiple aspects, multiple levels, and what we can learn about the climate change risk in Gujarat and vulnerability assessment for Gujarat state. So here is the list of publications that I have used, and these are also available in our lab website that is known as Water and Climate Lab, Indian Institute of Technology, Gandhinagar. And I would stop here. Thank you very much. I hope I have not taken a lot of your time. So it's roughly about 1 hour, I would say.
Thank you very much, sir, for enlightening us with very detailed presentation spread over 3 sections in your talk. I will now request Dr. Ulka Kelkar. She is the director of World Resources Institute India Climate Change Program. She will also deliberate on the subject, and after Ulkaji's talk, we will also take a few questions. So I have seen many questions directed to Mishra sir's talk. So we will have some of the questions addressed. So now, Ulkaji, your screen, you can share your presentation on the screen.
Thank you very much, Raji. I'll try to share my
Please
presentation.
unmute your mic.
Yes. That was stuff here. Not able to unmute. Not able to unmute myself.
Is there a full screen mode? Huh.
Hear me now?
Your voice is not clear, Ulkaji.
Are you able to hear me better now?
Yes, but your screen is not visible yet.
Sure, I'll share my screen right away. First of all, thank you so much to the Climate Department of Government of Gujarat for giving WRI India this opportunity for being a knowledge partner in this webinar series. It's an extremely timely webinar series because it's themed on climate change and COVID-19. Thank you also to the other knowledge partners, ICCR, IIT Gandhinagar, University of Baroda, who've been involved in today's webinar series. It's an honor for us to be part of this. I'm also seeing very active participation in the chat box, in the questions and answers from hundreds of participants. So thank you for your patience. I'll take only 10 minutes because Professor Mishra's presentation has been very comprehensive and he has highlighted all the nuances of how vulnerability assessment involves not just looking at the climate science in terms of the biophysical exposure of a system, but also looking at the social and economic aspects as well. What makes people more vulnerable? How is their adaptive capacity affected? So I'll not repeat any of those points, but I just wanted to say that what this current crisis, the COVID-19 crisis, has shown us is that economy, nature, and human health are all so closely connected that we can no longer try to solve one problem while ignoring the other problems. Everything is closely linked. And I just wanted to kind of say that this is something that has shown up not just in India, but also all over the world. And so climate change, as you all know, is fundamentally a global problem in which we all have a part to play. It's also something that happens much faster than you think. You think that it is something which is, because it is global, it won't affect you. But this is a chart. I hope you're all able to see it. which shows how the average temperature in Gujarat, I've taken the example of Gujarat over here in this chart, has increased over the last 100 years or so, right? And the blue lines are the ones which are lower than the average, the 1970 to 2000 average, so lower than what is normal. And the red lines are the ones which are higher than normal. So as you can see, and I've just added on top of this, that when my grandfather was born at the turn of the previous century, 1901, you can see there were a lot of these cooler years, meaning cooler than average. But the average itself has increased as climate change has happened. By the time I was born in the 1970s, there's been a mix of blue and kind of white years, almost yellow. And then my daughter in the decade, which has been the warmest decade that the world has ever seen. So, when we think of climate change as something for the future, it actually happens within the lifetime. And when my daughter grows up, this is something that will be her reality. This is a picture that actually my colleague took. So WRI India is also part of a network of research institutions. In WRI, we have an office in Washington, DC. And one of my colleagues got the chance to visit Antarctica. And as you can see from this picture, this is not what we have in mind when we think of Antarctica, right? You can see grass, and the penguin is moving on grass. So one of the things that is happening as a result of climate change, which people had not appreciated that much before, is that the ice melts, the permanent snow melts. There are new diseases, new pathogens that we are getting exposed to. And these are being called now zombie viruses. That is, they have laid dormant under the ice for decades or centuries, but are now coming out as the ice melts. And we don't have the immunity to these diseases. We don't have a cure or a vaccine for these diseases. So this is something that just shows how things like COVID-19, although it is like a once in a lifetime major crisis for us, is something that might not possibly happen again. The next point I wanted to make was something that Professor Mishra already has shown in his charts, that vulnerability is multidimensional. In parts of the world like ours, India, Asia, South Asia, Africa, there are so many problems and crises that we face. We face problems of water shortage. As he has shown, we have faced problems of floods and droughts. Another problem that you all must be aware of is that of locusts. And this is something which arises every year in Africa. The locust swarm moves from Africa, the Middle East, towards the western border of India. And there are always precautionary measures that are taken. This year, because of the COVID pandemic and the lockdown, we could do the usual kind of spraying and the kind of surveillance that normally happens in Rajasthan and Gujarat. So along with this crisis of locust swarms, which reached all the way up to Madhya Pradesh in our country, you have a problem of drought, you have a problem of food shortage, and you have a problem even of political conflict and wars in Africa. So when you look at vulnerability to climate change, we cannot ignore all these other dimensions, these other crises that are happening at the same time. Now, this is not something that is only of interest to people who love nature and environment or, NGOs. This is something that is now becoming a major problem even for businesses. So this is a picture from California, from the wildfires that happen in the summer. Again, something that used to happen quite frequently every year. But recently what has been happening is that the wildfires are becoming more severe because of a prolonged drought, because of climate change. Temperatures are higher, the wood is ready to burn. And who was held responsible? The power company or the electricity company, PG&E. And PG&E was told that you should have anticipated the risks of climate change and you should have made efforts to make sure that the electricity lines that you have are maintained better, that they should be put underground rather than above ground, and that you should maintain the trees by lopping off dry twigs and branches. And so billions of dollars of lawsuits were put for this company, and preemptively they announced bankruptcy. So this is something that was called the first corporate casualty of climate change. So with that background, I want to give 3 examples of work that WRI India has done on vulnerability assessment. These are not from Gujarat, but either for India as a whole or from other states. And this is an example from Madhya Pradesh that my colleagues have done. And it tries to show how, if you have areas which are vulnerable to, say, for example, over here, we are showing water risk. sometimes what happens is that we make certain changes in our policies which could increase that risk. So these are the red areas that you can see over here, the priority districts, as you can see marked over here, which have shifted to growing wheat. And these are also the areas which are highly stressed in terms of water availability. So it is important in vulnerability assessments to not just look at a snapshot at one point of time, but to look at dynamic vulnerability, how vulnerability changes over time as a result of our own actions, as a result of our own policy choices, and to make sure that the kinds of policy options we choose that is consistent, not just with the current level of risks, but also the future level of risks. So this, the source for this data is available at the bottom of the slide. At WRI India, all our work is usually in the public domain, not just the results, but even the models themselves. You can go to this website and you can decide which sectors you want to look at, which regions you want to look at, and which kinds of issues you want to look at. So there are many examples on this website. We have something called the Resource Watch, which you can all use, whether you're a student or a scientist. The second example I want to give is from the power sector. And here again, my colleagues have mapped the dark red areas are the areas which are highly vulnerable in terms of water shortages. And as you can see, Gujarat is one of those parts of the country which is facing problems. And on that, we have put these black dots, which are where the thermal power plants are located. And these thermal power plants use fresh water for cooling. It is only just a very few cases, I think, on the coast which are able to use ocean water, seawater. But otherwise, a lot of fresh water gets used. And when there is a drought or when there's a rainfall shortage, then these power plants have to be shut down. So again, this is an example of how vulnerability assessment needs to look at different sectors together, sometimes sectors which we don't often think of as together. Usually when we think of water, we think of agriculture first and foremost. But you should also look at sectors like the power sector. Yeah. And this publication is also available. And the third example I want to give is not so much vulnerability as possible solutions. And you would have seen a lot of emphasis these days on tree planting. And what WRI India, again, my colleagues from our landscapes program have done is that they've looked at how to restore areas, whether it is, say, the boundaries of agricultural lands, farmlands, or whether it is common areas which are degraded areas. But you can restore the kind of tree cover that is there, and with the right kind of fruit trees and other trees that are suited to the natural ecosystem, suited to the local climate, and which can also contribute to the livelihoods of the farmers. And this actually, this report is available. It's an interactive atlas which you can look at. The website is available. And what it does is we have gone further and tried to calculate what would be the economic impact. How much money could people get potentially, and how much carbon would get sequestered with soil carbon as a result of this. In India, this can help for India to meet its climate change commitments, its NDC on sequestration. But another thing that we are also doing is going one step forward and actually playing a kind of matchmaker between the farmers or local agencies and the market. So I'll be happy to provide more information about this. Just a couple of slides to end with, that the nature-based solutions like the tree restoration that I talked about is something that many countries, including India, have placed a lot of importance in the COVID-19 economic recovery packages. You must have seen a lot of big numbers of how much money is being invested in order to recover from this economic crisis. So as you can see, India is definitely paying a lot of importance to this. And just a last kind of thought, which is that if you look at past economic crises, like the one that happened in 2008-2009, countries which invested more in green measures were actually able to recover from the crisis faster. So the example here is Korea, which put as much as 70% of its stimulus package in green measures, renewable energy, electric vehicles, nature-based solutions. And compared to the rest of the Western countries, the developed OECD countries, they recovered faster from the crisis. So I'll skip this last slide because it's a little complicated. But basically, this is a detailed report that is available on the Global Commission Adaptation website, which shows that when you invest in things like early warning systems that Professor Mishra emphasized, making infrastructure resilient, investing in dryland agriculture, mangroves, and water resources, all the kinds of things that he spoke about, which are relevant for Gujarat, then the net benefits of such investments are 7 times what you invest. So these are from a global study, but I hope this has been useful for Gujarat as well. So thank you very much once again, and I'll be very happy to have WRI India associated with this webinar series. Back to you, Shweta. Thank you.
For again enlightening presentation. I will request Siraz Hirani to ask his question.
Thank you, Swetal bhai. My question is addressed to Professor Verma. I think in his presentation he mentioned about the climate change due to 2 reasons, the natural reason and the anthropological reason. So I just want to understand what percentage of today's climate change can be actually attributed to the anthropological reasons. Am I audible?
Yeah, I mean, as such, I did not look at that. What is the percentage or distribution? But if you look that figure that I have shown, the solar forcing or the climate change or rise in temperature that could have occurred because of natural factor is much smaller than that what have happened because of greenhouse gas emissions. So if you take the ratio of those two, you will figure out that the greenhouse gas emission contribution is very high, if that is not 100%. Okay, so I would say it's extremely high if you compare to natural regions. But accurate numbers, I mean, you have to take the data and do the estimates basically.
Okay, thank you, sir. Yeah. And I just want more clarity on the hazard and the socio-economical graph that you were presenting for the Gujarat. So is this atlas available in public domain?
So, I mean, this is the work in progress. Of course, this work has part of the work has been submitted to Gujarat Government of Climate Change in a form of report. Okay, but we are doing more, like we have looked at vulnerability because of not only rainfall extremes, but temperature extremes, droughts, water availability, and things like that. So, I mean, our part is to send this report to Gujarat Government of Climate Change, and I assume that sooner or later the Gujarat Government of Climate Change will make them public and put on their website. But as of now, these are not in public domain.
Okay, thank you, sir.
Sir, it will be published once we will finalize it. Now I will request Dr. Satyavrat Datta to ask his question. Satyavrat ji.
I think please ask him to unmute. Yeah.
Impact of racial lockdown on
Certainly, I cannot hear him. I don't know. You.
Yes, I think there is a problem with his audio. So I will request Deepa madam to ask her question.
And let me first congratulate the Climate Change Department for arranging such a nice session. The webinar where I am seeing a lot of participants are there. It's basically not a question, but as a part of the representative from Directorate General of Hydrocarbon, Noida, I am Deepa. I am the nodal for carbon capture, utilization, storage, and its application for the enhanced oil recovery by CO2 injection. So, as you are aware, that government is always promoting and emphasizing on the enhanced oil recovery techniques, and carbon capture utilization is a very, very effective method for energy security, addressing the energy security as well as the climate challenges. So we have taken some steps, like we are conducting a knowledge sharing sessions, and thank you very much this climate change department for supporting us, because I think we have approached them so that we wanted that whatever carbon dioxide is ejected in the Gujarat region and maybe all over India, we can always utilize it, and for carbon neutrality, that's very, very important. So my question with is one question that we were searching for with Mr. Mishra, Professor Mishra, if he's there. So my question is, sir, that do you have any anything mapped, any data where what are the major sources of carbon dioxide in your Gujarat region, in the region of Gujarat, and what is the concentration of carbon dioxide that is coming out? Because when we want to inject that into our reservoirs for enhancing the oil recovery, we need a particular concentration of CO2 in a pure form. So for that, we need to know that what are the sources in Gujarat that are emitting the carbon dioxide, and whether they are near to our reservoir. So we would like to get that data if you have.
So, I mean, thank you very much for your question, and I think it's extremely important. So, as I mentioned in my talk, that I am Ahmedabad, and IIT Gandhinagar are involved in the revising the state action plan on climate change for Gujarat. So, of course, I mean, mapping of or doing getting the inventory is part of that exercise, and that is being done by Professor Amit Garg of IIM Ahmedabad. So I would basically suggest you that if you need anything, you can drop him an email, and Swetal Bhai has his contact details. He may probably share if you don't have already. And I think whatever information is available with us, if it becomes useful for you, and if there is no restriction on sharing the information, we would be happy to share. Okay.
Thank you very much. Thank you. Mr. Sheetal will be coming back to you on this. Thank you.
Sure, ma'am. Sure. We will coordinate for that part.
Thank you for giving the opportunity. Thank you.
I'll request Nikhil Deshpande to ask his question. Nikhil. And next, Preksha Joshi, if available.
So,
Please.
as it's known that major climate changes, it results due to human activities and particularly industries, and also many measures may have been taken to into implementation, but still there is not much changes in the present scenario, right? So can you please elaborate that the effective efforts which are going to be implemented and those which have been already implemented for the climate change resilience? Thank you.
I mean, your question is very interesting, but I would say that I showed in my talk that three important or most important graphs related to climate change. And if you go back, you will see not only industry, but electricity generation, food habits, food production, land use change. These three are the major player for GHG emissions or greenhouse gas emissions to atmosphere. Now, what is being done for the climate change mitigation? I mean, there are number of activities at different levels, starting from local to regional to global scale. For instance, India has started this global solar alliance, and Gujarat is Gujarat is playing a key or leadership role in that. So, getting more and more electricity from renewables, right, is one of the I think it's a challenge, but we have made tremendous progress in that direction. And now the solar generated electricity is as cheap as grid based, or maybe cheaper than that. So there is a progress in terms of mitigation, but also there are challenges, and challenges most are basically associated with the disparities at economic level or development level in different countries or in different regions, right? So everybody has right to develop. India, China, or within India, all the states have equal right to get developed and improve their living standard and so on and so forth. So I mean, because of these challenges, the uniform action across the globe, or there is not much consensus across the globe that how we should lead in terms of mitigation, and that has been a problem when we talk about mitigation. And there have been number of agreements like Paris Agreement, COP 21, 22, 26, and so on and so forth. But the consensus that how we should go ahead and what is the difference of opinion in terms of developing countries, developed countries, the availability of technology for energy efficiency, or the availability of finances to increase your renewable energy production. I mean, these remains open challenges where we all have to sort of work on.
What, sir?
I think we are constrained by the time, so I'll take just last question. Shweta Madam, Dr. Shweta Rajpurohit, uh, please ask your question to Ulka ji.
Okay, thank you, Shwetal ji. Good afternoon, everyone. All the presentations have been very interesting, and thanks to the speakers for showing us this interesting information. My question is to Dr. Ulka ji. Thanks, first of all, for your interesting insights into so many aspects and the research studies that WRI has been doing across the world, specifically for India. I was just thinking that your studies are always so interesting and application oriented. And under this COVID situation, can we think of a study planned pan India, which really correlates how biodiversity loss and forest ecosystem loss is actually triggering, triggering the outbreak of diseases like COVID or SARS and MERS. And we all accept that all these diseases and pandemics are actually coming from the wilds or from the biodiversity to the humans. So there should be a surveillance in place for which some organization can take a lead and undertake a pan-India, study wherein state organizations, state expert organizations like, the foundation or other departments can really come forward and collaborate. And it will really throw a good light on how to contain the spread of these pandemics to humans as host. Over to you, Alkaji.
Thank you. That's a very fantastic idea, but difficult question to answer. I think you and maybe under the, with all the organizations that are involved in this webinar series, would in fact design such a research study. The challenge is that necessarily studies which relate to health and biodiversity loss have to be long-term in nature. You need to take data over a relatively long period of time. It's not something that can be done in just with data for 1 or 2 years. But having said that, I would like to just point out that there is a study that has been done by researchers at ATRI, the Ashoka Trust for Research in Ecology and Environment, from the Western Ghats, Kerala and Karnataka, on something called a Kyasanur forest disease, where there were outbreaks right from the 1950s till the present time. And people have got affected because they went into the forest, either they were forest officers or they were just people collecting firewood. And it is a monkey-borne, tick-borne disease, which causes hemorrhagic fever and sort of serious death. So they are definitely looking at this over the long term. Terry and EPIC, the Chicago school, which is located in Delhi, they have also separately looked at how climate change will affect the window for malaria transmission. So that is not because of the biodiversity loss specifically, but because of temperature rise and humidity changes. So those are also examples of studies that have been done. I'm sure there are others that I'm not aware of. But definitely this is a much needed study, and thank you very much for raising this. And I just wanted to end by thanking again the Principal Secretary, Mr. Haidar, Joint Secretary, Mr. Mukesh Shah, Data Director, and Shweta to yourself. Thank you very much again for the opportunity to be part of this very vibrant discussion and very interesting ideas that have come up. Thank you so much.
Thank you all. We have many more questions. Due to the time constraint, I will now request Shri S.B. Patil of JEDA to give vote of thanks.
Hello, all of you. On behalf of the Climate Change Department, I extend you a very big thank you to all of you, especially Professor Vimal Mishra for his very comprehensive and detailed, insighted presentation on the vulnerability assessment and its methodology for mitigation. I also thank Dr. Sanskriti Mazumdar as well as Ulka Kelkar for their insights on the subject. I thank you all the participants, and thanks are due to our Principal Secretary, Sri Haider sir, and our Director, Sri Bijal Shah sir. It was a very informative webinar, and hope the participants have benefited out of that. And we will continue our stride to conduct such a series of webinars covering various subjects on climate change, which will be of great interest to all. Once again, thanks all of you. Thank you.